What you're about to see is not CGI, it's not a movie prop, it's not a concept render for some tech startup's pitch deck. It's a 500 kilogram machine with a human being sitting inside its chest, walking on two legs, punching through a brick wall, and then folding itself into a four-legged crawl. And it went into production 2 weeks ago. 2026 has already delivered 3 robots that have genuinely moved the goalpost for what the industry can do. Not in a lab, not in 5 years, right now. A rideable transformer built for disaster zones, a human that just clocked its first real factory shift, and a machine that sprinted at 22 miles per hour in a real-world test and made every previous speed record look quaint. So, if a mech suit, a rugged work robot, and the fastest bipedal humanoid aren't heralds of the age of Skynet, I don't know what is. Now, on May 12, 2026, Unitree Robotics released a 1-minute video that stopped the robotics world in its tracks. The company's founder, Wang Xingjing, climbs into an open cockpit mounted on the torso of a giant red machine, takes the controls, and walks it across a workshop floor. The robot strikes a stack of bricks with one arm and collapses the entire pile in a single motion. Then, it reconfigures its chassis and drops it into a four-legged stance. The whole sequence takes seconds. This is the GD01, and Unitree is calling it the world's first mass-produced man-transformable mecha. That description is accurate. The machine weighs approximately 500 kilograms with a pilot on board, stands roughly 2.8 meters tall in bipedal mode, and is built from high-strength alloy designed for real civilian applications. The starting price is 3.9 million yuan, which translates to somewhere between $537,000 and $574,000 depending on current exchange rates. This is not a prototype. Unitree has confirmed it's going into production now. The engineering case for the dual motor design becomes clear the moment you think about where this machine is meant to operate. Bipedal walking gives the GD01 the reach and range of motion needed to navigate environments built for people, move through rubble, or interact with structures at height. Quadruped mode provides stability on uneven and unpredictable terrain where a two-leg configuration would be a liability. Together, they cover terrain that no existing civilian vehicle can handle. This is a practical argument for why this configuration exists, and it is a strong one. The control architecture draws from Unitree's established humanoid line, running motion control loops at close to 1000 Hz, combining reinforced learning for adaptive behavior with model predictive control for real-time stabilization. A full technical specification including battery runtime and autonomous range has not yet been published, but what has been demonstrated is already proof of concept for a class of vehicle that the industry has theorized about for years without being able to build it. Unitree is positioning the GD01 for tourism, commercial transport, and rescue operations in challenging environments. The company is simultaneously filing for an IPO on Shanghai Star Market with plans to allocate over 2 billion yuan towards further robotics development. The ambition is clear, and given that Unitree managed to bring the cost of capable robot dogs down to levels that research institutions and individual buyers could actually afford, there is every reason to take seriously the idea that this technology becomes genuinely accessible over the next decade. The GD01 is the first step in that direction, and it is a significant one. Now, for most of its public life, Boston Dynamics operated under a specific and persistent criticism: extraordinary engineering, no commercial application. The viral videos were undeniably spectacular, but the real-world utility was, well, theoretical. That criticism no longer applies. On January 5, 2026, at CES in Las Vegas, Boston Dynamics unveiled the production version of the all-electric Atlas during Hyundai's Global Media Day. The announcement came with a detail that made the entire robotics industry take notice. Every single unit in the 2026 production run is already committed. Hyundai's robotics Metaplant Application Center in Georgia and Google DeepMind have claimed the full output before a single robot ships. That's not a company managing expectations, that's a company with more demand than supply. Now, the Electric Atlas is a ground-up redesign. The hydraulic system that powered the previous version, which was noisy, prone to leaks, and difficult to maintain in clean industrial environments, is gone entirely. In its place are custom electric direct drive actuators supplied by Hyundai Mobis, built to automotive manufacturing tolerances. The result is a robot with 56 degrees of freedom, nearly triple the articulation of the hydraulic version, with many joints capable of full 360-degree rotation. These are ranges of motion a human body can never achieve, and Boston Dynamics is not trying to replicate human movement. The design goal is efficiency in spaces built for people, which is a meaningfully different and smarter target. The operational specifications are built for industry reality. Atlas can sustain a payload of 30 kilograms and burst lift up to 50 kilograms. Its IP67 rating means it's fully dust tight and it can be hosed down on a factory floor without issue. All limbs are field replaceable in under 5 minutes, keeping downtime manageable. And the autonomous battery swap capability, where the robot walks itself to a charging station and completes the exchange in under 3 minutes, means it does not require constant human supervision to stay operational. Now, the intelligence layer comes through a partnership with Google DeepMind, integrating large behavior models that allow Atlas to handle unstructured environments. This is a capability gap that has historically separated humanoids from traditional industrial robots. Fixed path automation fails the moment something is out of place. Atlas is designed to assess and adapt whether a part spin has shifted or a component has been dropped, or maybe the task requires a variation it has not been explicitly programmed for. Once it learns the task, that skill can be deployed across the entire fleet immediately. Hyundai has announced plans for a dedicated robotics factory capable of producing 30,000 Atlas units per year, with tens of thousands of robots targeted for deployment across its own global manufacturing facilities. This is a company that owns both the robot and the factories it will work in, which removes nearly every barrier to scaled adoption. The industrial humanoid has been a theoretical proposition for a long time. Atlas has made it operational. Now, there's a specific kind of moment in any technology field where a demonstration lands and the reaction is not excitement, but disbelief. When the footage of Bolt surfaced in February 2026, that was the reaction across the robotics community. A full-size humanoid robot running at 10 meters per second in a real-world control test facility on its own 2 legs. That is 22 miles per hour. That is faster than most trained athletes sprint, and it is now a documented real-world record. Bolt was developed by MirrorMe Technology, a Shanghai-based company founded in 2024 with a core research team drawn from Zhejiang University. The name, of course, references Usain Bolt directly, and the machine earns the comparison in purely mechanical terms. Standing 175 centimeters tall and weighing some 75 kilograms, it occupies the same physical range as an average adult human, which MirrorMe describes as the ideal form for a robot expected to operate in human-built environments. The design is not oversized or exaggerated. Every dimension has been chosen to balance human world compatibility with structural demands of extreme locomotion. The way Bolt achieves its top speed challenges the intuition of anyone who has watched human sprinters. Rather than extending stride length, which is the primary mechanism humans use to accelerate, Bolt increases cadence, taking shorter steps at a dramatically higher frequency. This keeps the center of mass more stable through the gait cycle and reduces the time each foot spends off the ground, which is where instability accumulates. The engineering team described the performance as a breakthrough in human locomotion control, dynamic balance, and high-performance drive system. The key word here is control. Raw speed on a straight track is one thing. Maintaining balance, structural integrity, and controlled deceleration at those speeds is an entirely different and much harder problem. And Bolt solves both. MirrorMe's long-term goal is what the company calls super species robotics, machines that approach or exceed human athletic capability while maintaining human-level environmental awareness and physical perception. That near-term application they have identified is using Bolt as a training partner for elite athletes, a robotic pacer that can sustain speed no human coach or training partner could match. This is consistent with MirrorMe's trajectory. Their previous platform, Black Panther 2, ran 100 meters in 13.17 seconds on live Chinese television in 2025, a benchmark that reportedly exceeded comparable Boston Dynamics speed tests at the time. Bolt represents the next step in research program that has treated speed as its primary metric since 2016. The broader applications follow naturally from the capability itself. Emergency response operations where arrival time determines outcomes, search and rescue in collapsed structures or hazardous terrain, high-speed material handling in logistics environments that current systems simply cannot keep pace with. Bolt is the current record holder in humanoid locomotion. More importantly, it demonstrates that the physical ceiling for this class of machine is considerably higher than the field had previously assumed. 3 robots, 3 completely different engineering philosophies. One designed to carry a human into places vehicles cannot, one built to work in an industrial shift without supervision, one that outruns the humans who built it. What connects all 3 is not just the technology, it's the timeline. The GD01 revealed on May 12, 2026, Atlas entering production in January and shipping to Hyundai within weeks, Bolt setting a humanoid speed record in February. This is not gradual progression. The gap between remarkable demonstration and operational deployment has collapsed in a way the industry did not expect this quickly. So, are we on the brink of creating the world a much nicer place, or are we creating a monster that will consume us? Be sure to tell me your opinions in the comment section down below.